Today we will solve one rectangle where charges are also different, Q1, Q2, Q3, Q4, and in that case how will I solve it? Okay, so take a look. So 16th question. See, even if that fellow doesn't give me x-axis, y-axis, I will eventually draw x-axis, y-axis of my own. Meaning, he will say that four charges are placed at the vertices of a rectangle of length L and breadth B. So let us say this is A, B, C, and D. This is the rectangle, and the charge at A is Q1, charge at B is Q2, charge at C is Q3, and charge at D is Q4. Okay?
Yes, sir.
And he will say find the force on charge at C due to A, B, and D. Okay?
Yes, sir.
Find the force on charge at C due to charges at A, B, and D. So what I will do is I will take this as x-axis and this line as y-axis. Okay. Now automatically I will take A as origin, B will become L comma 0, correct?
Yes, sir.
Point D will become 0 comma
0, B.
and point C will
L,
be
B.
L comma B. Okay, this is done.
Yes, sir.
Next, what we will do, we will draw the lines of forces. The force due to charge at D, I will draw it as FD because all are positive charges. Okay.
Yes, sir.
The force due to B, I will take it as FB, and the force due to A, we will take it as FA. Is this clear?
Yes, sir.
Simply, we will now start writing. First, I will start off with FC. There is no FC. First, we will start off with FB. Okay, in the upward direction. And I will directly write its vector form also. So it is K. Tell me what it is.
K, Q2, Q3 by B square.
J cap.
Yes, sir.
Clear? Is this visible?
Yes, sir.
Okay. Next, we will write FD bar. How much is FD bar?
K, Q4, Q3 divided by L square. I can.
Okay. Now,
AC.
from A to C, right?
Yes, sir. K, Q1, Q3 upon L square plus B square.
First, I will write the magnitude of FA bar because what you're telling is magnitude, right?
Yes, sir.
K Q1 Q3 by L
L
square plus
square
B
plus B
square
square.
because that is the The length of this diagonal is going to be square root of L
L
square
square plus
plus
B square.
B square. Right?
Yes, sir.
Now one thing.
Into I cap.
Ah,
It should be Li cap plus Vj cap upon under root
let me
L.
do that. Correct. That is correct only. So how I'm going to do that is I'll take this angle as theta 1.
Yes, sir.
So in terms of theta 1, what is the unit vector along that direction? So because you're telling me the unit vector, then I will write the vector itself. Okay. So k q1 q3 divided by L square plus B square into, we need unit vector in that direction. We got the
Yes, sir.
magnitude unit vector. What is the unit vector in terms of theta 1?
L I cap plus Bj cap
Divided by,
divided by under root of L square.
yeah, in terms of theta 1, I am say asking you. So it is cos theta 1 I cap plus sin theta 1 j cap.
Oh, okay, sir.
Then you can say cos theta 1 is L by square root of, right? From the
Yes,
figure, we can say cos theta 1 is equal to L by square root of L square plus B square, and sin theta 1
that is kind of representation of a normal form.
normal form.
Sir, cos theta x plus sin theta y is normal form equal to P.
Okay, it's too much English. So
It's math.
eventually the answer is what you said only, which is L I cap plus B j cap, and we get under root of L square plus B square. Fine.
Yes, sir.
So now let us do the vector addition of all these things and write it in terms of I cap and j cap. So force on the charge C, which is resultant force, is equal to summation of these forces, Fa bar plus F
D bar.
D bar plus FB bar.
Yes, sir.
So first I will take K outside because K is common for everyone. I
Hmm.
think Q3 is also common for everyone, right?
Hmm.
Correct?
Yes, sir. Yes, sir.
So I will take K and Q3 outside. Now I have I cap here, I have I cap here. So first let us write the I cap of this, which is Q4 by L square
L square I plus
plus I cap for this
Q Q.
L square plus B square whole to the power 3 by 2 I cap.
Yes, sir.
Correct. Next,
Yes, sir.
Q3 by B square,
Q2 by B.
Q2 by B square, Q2 by B square plus
Q1 by
Q1B by L square
L
plus
square
B
plus
square
B square.
whole to the power 3 by 2.
Yes, sir.
This is J cap. Clear?
Yes, sir.
Xerox. So this is a general form in rectangle. Same square also, yesterday we did the same thing. I cap, J cap, K cap, and just add it. So if we have square, triangles, rectangles, or polygon also in that mat, if you just draw I cap, J cap, find the individual forces in terms of I cap, J cap, and add them. That's the best way to solve these questions. Okay,
Yes, sir.
take it.
But for this cos theta 1 I cap plus sin theta 1 j cap, is it that it's always defined like that, so you wrote it in that way?
Any unit vector at an angle theta 1 can be written as unit vector cos theta 1 I cap plus sin theta 1 j cap.
Yes, sir.
Any
Like credit sides we used to do.
any unit vector, because how can I say it is unit vector? Magnitude of it is 1, square root of cos square theta 1 plus sin square theta 1
Yes,
is.
sir. It should be
And
reversed if we take the other side.
uh, if we call the other side as theta 2,
Yes, sir. It should be sin theta
2 I cap
sin
plus
90 minus theta.
sin theta 2 I cap plus cos theta 2 j cap.
J.
Because simply wherever the angle is, cosine will be the adjacent I
Yes,
cap,
sir.
and sine is the opposite j cap. If this angle is theta 2, we will do cos theta 2 j cap and sin theta 2 I cap.
Yes, sir.
We will start off with electric field.
Yes, sir.
So, like I told you, all the concepts of electrostatics can be discussed in one lecture. But the problem is we are not much habituated with vectors. That is one problem. Another problem is it is not good to stress in one lecture so much. And we have time, so therefore we are going slowly. But otherwise, so there are four physical quantities in electrostatics chapter. Mainly, till now we have discussed electric force.
Yes, sir.
Now we are going to discuss electric field. Okay, pretty straightforward. We have discussed electric force till now. Now we will discuss electric field, and that means out of four physical quantities, we have discussed two. Another two will be remaining, which will be electric potential and potential energy.
Yes, sir.
These are the four main physical quantities that we need to study in electrostatics. Simple. Okay.
Yes, sir.
So let's begin with the electric field. So we said first we will discuss point charges, then we will discuss distribution of charges. That means charges distributed over length, over area,
Yes, sir.
over volume, then why am I not discussing the charge distribution? Because first I want you to understand what is the definition of electric field and how finding electric field will eventually cover finding electric force. Simply, if I have, let us say I have a charge Q over here at a point A,
Yes, sir.
and at a distance of R at a point B, I have a test charge over here.
Hmm.
We
Sir,
start
what is that?
we start using this test charge from here onwards, meaning that I want to place a charge over here, but I am only using this charge as a test charge. I will not actually be requiring it. You will see what we mean when we write the equation.
Yes, sir.
For now, I am calling it test charge. Let this charge be Q, that charge be Q test. Now, the force due to Q on charge at B, let us say, is F.
Sir, so that charge cannot move.
Neither of the charges are moving, both are fixed. Both are fixed.
Hmm.
The force due to charge at A on the test charge, let me say it is capital F.
Yes, sir.
So I will write capital F as what? K Q into Q test divided by R square,
Yes, sir.
right?
Yes, sir. Okay.
And just to put it vectorially,
Okay.
I will write it as R cap,
Yes, sir.
unit vector, because I am writing this as R bar.
AF bar, right, sir.
This will become F bar, vector form. So we are done. Definition of electric field. Electric field. It is very important to understand the language over here. The electric field due to charge Q at point B, let us say this is E bar. The electric field due to charge Q at point B. That means at that location, what is the effect of the charge? Just like gravitational field is 9.8 meters per second square, right? Acceleration due to
Yes,
gravity.
sir.
So, what are we trying to understand in terms of Earth? We are trying to understand the effect of Earth at this location.
Hmm.
Similarly, the effect of charge Q at point B. Clear?
Yes, sir.
I am calling that electric field due to charge Q at point B as E bar, and the E bar is defined as the electric field at charge due to charge Q at point B will be equal to the force that is applied on the test charge divided by the test charge. If I place a test charge at B, how much force F bar will it experience? The force experienced by the test charge due to this charge Q divided by the same test charge that I've placed over there.
Yes, sir.
So now substituting, we will get this as test charge divided by R square divided by test charge, right?
Yes, sir.
Into R cap. So simply this will become E bar is equal to, due to point charge, is KQ by R square into R cap.
Sir, so F bar by test charge is already defined that. I mean, F bar for electric field.
The definition of electric field is the force acting on the test charge divided by the test charge. The force
Yes, sir.
experienced by the test charge divided by the test charge that is present over.
Mm.
In this case, we are finding the electric field due to charge Q. So I am writing the force due to charge Q on test charge.
Yes, sir.
Suppose I have multiple charges, then I will write the force due to all the charges experienced by test charge divided by test charge. Either which
Yes,
way,
sir.
the definition of electric field will be electric field is force experienced by the test charge divided by the test charge present over there. And eventually, if you see, the electric field is independent of the test charge that I place.
Yes, sir.
Electric field is independent of the test charge that I place over there. Clear?
Mm.
So I
Yes.
don't have to bother, like you said, what is this test charge? This test charge is a charge that I am placing over there so that I can find out how much force is being experienced by it. But then I
Yes,
will
sir.
divide it by the its own value, which eventually will make it independent of the test charge present over.
Yes, sir.
Next, second point is, if the definition of electric field is force divided by the test charge, this also means I can say that the force experienced by the test charge is the test charge into the field that is present over there. Can I say like this also?
Yes, sir.
The force experienced by the charge placed at point B. You call it test charge, you call it whatever, that's our wish. But the force experienced by a charge placed at B can be written as the charge value into the electric field that is present at that point.
Yes, sir.
We can say like this also, right? Now,
Yes,
why
sir.
am I telling you this form is because we have done forces due to point charges on point charges.
Mm.
Then we had to do forces due to charge distributed charges on a point charge.
Mm.
But what am I saying? I don't have to do forces due to charge distribution on a point charge, because anyways I am going to do it in electric field due to point charges at a particular point, field due to charge distribution at a particular point. Once I know the field, I will know the force.
Yes, sir.
Instead of talking everything in air, just a small examples I'll give, random examples. not literally, we are not doing anything. So let us say I have bunch of charges Q1, Q2, Q3 randomly placed. Now I need at a point A, I want to find the force that is placed, that is on the charge Q4.
Yes, sir.
I want to find force on Q4, Q2, Q1, Q2, Q3. Okay.
Hmm.
So what will I do? Find the electric field at point A due to Q1, Q2, Q3. Right?
Yes, sir.
Find the electric field. Then multiply the charge with that electric field at
Okay.
point A.
Hmm.
Is this clear?
Yes, sir.
Find the force due to these charges on that charge. I will find the field due to these charges at that point. Language is very important. Field due to these charges at that point
Hmm.
and multiply by the test charge that is placed over there.
Yes, sir.
Is this clear?
Yes, sir.
Similarly, let us take another example. Let us say there is charge distributed over this rectangular plate, which we will do eventually. And at a point A, there is a charge. Let's say this is capital Q and this is some charge small q.
Yes, sir.
And the question is find force on small q. On small q due to capital Q.
Yes, sir.
On small q due to capital Q. Right?
Hmm.
So what will I do? Find the field EA bar. Right? Because then the
Yes, sir.
force will be charged into EA bar. Is this clear?
Yes, sir.
Let us say 17th question. I'll solve this. Okay.
Okay.
We have already solved this question, but I want to solve it again. Okay.
Yes, yes.
So we have x-axis, y-axis. Let us say we have a square of side A. There is a square of side A. We solved this yesterday.
Yes, sir.
In this, what we are saying is O, A, B, C. Let there be three charges plus Q and plus Q placed at O, A, and C. Okay.
Yes, sir.
All we have to do is find the electric field at point B. Find electric field at B. Okay.
Yes, sir.
So again, repeat of the same thing. I will say first I will draw the lines. Field due to C at B, I will show it as EC in this direction. Field due to A at C at point B, I will
Hmm.
write it as
Yeah.
EA in this direction. Okay.
Yeah.
and field due to O at this point, we will show it in this direction, EO. Okay.
Yes, sir.
Now, EC bar is what? KQ by A square I cap
Yes, sir.
in that direction. EA bar
KQ by A square.
J cap. And what is EO bar? Electric field due to charge at O.
KQ by 2A square into I cap plus J cap by root.
KQ by 2A square into unit
I
vector I cap.
cap plus J cap by root.
Good. I cap plus J cap divided by root. So simply the resultant electric field, that is electric field at point EB, at point B, vector form is, I will take KQ by A square common. Okay.
Yes, sir.
So we have this as 1 plus 1 by 2 root 2 I cap plus 1 plus
1
1
by
by
2
2
root
root
is.
2 J cap. This is our field.
Yes, sir.
Now, if small q is placed at point B,
Yes, sir.
if small q is placed at point B, then the force on that particular point, on that particular charge, will be nothing but q times EB bar, and that will be the answer if you see in the previous class.
Mm.
KQ square by A square into so and so and so. Is this clear?
Yes, sir.
Easy?
Yes, sir.
We just need to find electric field and multiply by the point charge that is placed at that particular point. Now also understand, when we are studying an effect, obviously we will study the effect at a point, right?
Yes, sir.
Suppose my ear is paining, I will focus on that particular point where my ear is paining.
Mm.
So when we are studying an effect, we will always study at that particular point, and
Yes, sir.
that itself will accomplish. If I place a point charge over there, to find the force on the point charge is to find the field at that point into the charge that is placed over there.
Mm.
Clear? Simple.
Yes, sir.
Find the field at that point and multiply it with the charge that is placed over there. And
Sir, K is also responsible for the effect on.
yes, K is basically the science behind it. K is 1 by 4 pi epsilon naught, and epsilon naught is permittivity of free space, and
Then,
permittivity is basically the science behind why this electric field is present and why the force is able to act. The basic reason why electric forces or electric fields are existing is permittivity, is K,
mm.
right? Let us
Yes, sir.
just solve one more, okay? And then tomorrow we'll go for more electric field questions.
Yes,
Okay.
sir.
I think we solved this also yesterday. So let us take 2 points minus a comma 0, let us take a point over here 0 comma 2a. I think we did this, right?
Yes, sir.
Let us place minus q charge over here, plus q charge over here. Take this point as a, this point as b, and let us say this point is c, 0 comma 2. We need to find the electric field at point c due to the charges placed at point a and b.
Yes, sir.
Now, let me solve it. Simply, one good thing is we have symmetry over here. Okay.
Mm.
So, field due to positive charge will be in that direction. Field due to negative charge will be in this direction.
Yes, sir.
Field is also a vector, right?
Mm.
So, it will have directions. So, the field due to positive charge will be in that direction. Field due to negative charge will be in this direction. The magnitude of the charges are the same, the distances are also same, there is symmetry. Therefore, I can say that the magnitude of the electric field over here and here is E
Mm.
due to symmetry and due to charges, magnitudes of the charges being same. Next, this is symmetric along x-axis. So I know the resultant will be along negative
Yes.
x-axis direction.
Yes, sir.
And if you remember, the story starts off by saying, let this angle be theta. Okay.
Yes, sir. So
If this angle is theta, yeah. If this angle is theta, this angle is 90 minus theta. Sorry, this angle is theta. If that angle is theta, this angle is also theta because of symmetry, right?
Mm.
Symmetry.
Yes, sir.
This is theta, this is also theta. This is 90 minus theta. Correct? This angle is 90 minus theta. So this angle will be theta.
Mm.
And the magnitude over here, we are saying it as E. So we know the resultant is going to be 2e cos theta in the negative x-axis direction.
Yes, sir.
So the final answer simply E net resultant vector at point C is going to be 2e cos theta into minus I cap. Correct?
Yes, sir.
What is E? E is equal to charge due to one particular field due to one charge, right?
Yes, sir.
K q by distance square. See, this distance is A.
Mm.
This is 2A.
Yes, sir.
How much was the hypotenuse?
Root 5.
A root 5, right?
Yes, sir.
Simply we have A root 5 whole square.
Yes, sir.
This is E. What is cos theta from this triangle?
A 1 by root 5.
1 by root 5. We got it yesterday. So simply substitute. Okay.
Yes, sir.
So field we are getting it as what? 2kq by 5a square into cos theta is 1 by root 5 times minus I cap. Is this clear?
Yes, sir.
So basically the resultant is going to be minus 2 by 5 root 5 kq by a square I cap. This is going to be the field at point C vector form. Is this clear?
Yes, sir.
Now, if see again, what was the question that we did in force? If small q charge is at placed at point C, then force on that charge at C, force on that charge at C is simply charge into the electric field. Clear?
Yes, sir.
That means basically we will get the answer as kq square. I'll write the number first. This entire thing divided by small q, right?
Yes, sir.
Right? So minus 2 by 5 root 5 kq square by a square I cap. And this is what we had yesterday solved.
Hmm.
Is this clear?
Yes, sir.
So why are we mainly finding out field for now is to find the force.
Hmm.
For now, field has many more expressions and many more usages and many more understandings. But at least for now, what we are doing is we are trying to find the field so that we can find the force.
Yes, sir.
Okay, we will uh, do a lot of things. I just don't want to put any words right now because don't corrupt yourself. Did you understand?
This I understood, sir.
That's it. That's all I want. Because, like you said, magnetic field, magnetic field, magnetic field. Because some Baba had placed magnetic field in your head too much. So, we will obviously once. What will we do in magnetism? We will do that only. Right?
Yes, sir.
But how magnetic field and electric field,
I mean, we can say that, but
why didn't you take the name of gravitational field? What did that poor thing do then?
I had doubt there also, sir.
So your doubt in general is a common doubt. I will explain.
Yes, sir.
Your doubt is when we are saying field, does all these fields more or less mean the same?
Yes, sir.
Or your doubt to be more precise, what exactly is a field? Because you are using it for gravitation also, you're using it for electric field also, you're using it for magnetic field also. So what is this field?
Yes, sir.
Field is the presence of the effect through a region
Yes, sir.
in a space, the effect that passes through is present through a particular region. Now we have Modi field in our country.
Yes, sir.
So, the thing is, field is nothing but the presence of the effect due to a certain thing, and that presence is there through a given region.
Hmm.
Earth has gravitational field surrounding it
Yes,
in
sir.
the region.
Hmm.
Earth has gravitational effect on moon also, so that means it has field over there.
Hmm.
So gravitational field due to earth, which is present through this three-dimensional space. So what can I call an effect that is present through a particular region, in a particular region? Why I'm saying through is because as I keep going altitude wise higher and higher away from earth, the gravitational field keeps decreasing and it's a continuous function.
Hmm.
So I want to express a particular presence of effect due to earth as a continuous function in a given space.
Yes, sir.
I call it field.
Yes, sir.
It's not like the gravitational field due to earth in second floor has nothing to do with gravitational field at third floor. It's a function of distance,
Yes, sir.
right? So the
Yes,
idea
sir.
why I said continuous function is because the function of distance. As the distance is varying, the magnitude is varying. It's not a discontinuous function where the gravitational field will not work at 2.5 floors. There's no such thing like that.
Yes, sir.
Gravitational field is there everywhere as I go from second floor to third floor, and it's varying continuous.
Yes, sir.
Is this clear?
Yes, sir.
So, what in general is a field? Field is the effect due to a particular thing in a given space as a continuous function.
Yes, sir.
Here,
Yes, sir.
enough pravachan for today.